Welcome to my second kinematics video, and in this video we're going to walk through a free fall kinematics problem. Free fall refers to any time you drop something and it falls to the ground under the acceleration of gravity. So here is the problem. An object is dropped from 320 meters high, and it's asking us to find the time of motion. In other words, the time that it takes to hit the ground and the velocity when it hits the ground. So, I'm going to start with step one, which is draw a diagram. And so the problem says an object is dropped from 320 meters high. So, let's just say our object is an egg. And this distance right here is 320 meters. And the object is moving under the acceleration of gravity from the Earth, and that is equal to 10 meters per second squared. And so when you have a free fall problem, there's a couple of other things you need to consider when you're drawing your diagram. And the first thing is whenever you drop an object, you assume you're dropping it from rest. In other words, you're holding it and then letting it go. And at the instant that you let it go, the velocity, the initial velocity, is still 0 meters per second. That's the first thing. The second thing, which will make the problem solving much more simple, is if you set its initial position to x, I equals 0 meters. Because a lot of times in free fall problems, we're going to be using this equation right here. So, if you have xi equals 0 and vi equals 0, then it simplifies this equation and you don't have to worry about rearranging it as much. So we drew our diagram, and now let's go through and find our givens. So here's one, 320 meters high, and here's the other one, the acceleration of gravity, 10 meters per second squared. So those are the two that are given to us in the problem. So I wrote this backwards. So let's just say x equals 320 meters and acceleration equals 10 meters per second squared. And what else did we determine? We determined our initial velocity is 0 meters per second, and we set our initial x position to 0 meters. And our unknown, the first thing it's asking us to solve for, is the time. And that's given right here. Find the time. Find the time of motion. So time is our unknown. And our equation is this one, right here. That is our free fall equation. And most of the time when you're doing free fall problems that start from rest, you're going to want to use this equation right here. So our equation is delta x equals x initial plus velocity initial times time plus 1/2 times the acceleration times time squared. And so let's look at this and see how we can simplify it right off the bat. So x initial equals 0, so delta x equals 0 plus velocity initial equals 0 and times time is 1/2 a t squared. So I just plugged in those zeros to show you that you can get rid of these right off the bat. And you're left with delta x equals 1/2 half acceleration times time squared. And we're trying to solve for time, so we need to get t by itself. And let's start all the way over at the left with this 1/2. And the first thing we need to do is get rid of that 1/2. So we multiply both sides by 2. And if we multiply this by 2, 2 times 1/2 equals 1. And anything times 1 is the same thing. So let's get rid of that 1/2. We can get rid of this 2. Now we have 2. Delta x equals at squared. Next thing, moving over to the a. How do we get rid of the a? Well, the a is being multiplied by t squared, so we're going to divide it out. And dividing it out on this side cancels out. We have 2 delta x over a equals t squared. And we don't want t squared. We want t by itself. And the only way to get rid of an exponent of 2 is to take the square root of it. And anything we do to the right side, we have to do the left side. So taking the square root of t squared leaves us with t equals the square root of 2 times delta x over a. And so now we are going to substitute our numeric values into this equation. So 2 times delta x, which is 320 meters, divided by a, which is 10 meters per second squared. And now all we got to do is solve it. So t equals the square root, let's see, of 640 meters divided by 10 meters per second squared. So 640 divided by 10 is the same thing as 64. So t equals square root of 64, and we can match these units up. It's meters squared divided by seconds squared. No, that's not right. It's seconds squared, because these two cancel out. And this moves to the top. But if you know you're looking for time, you don't need to worry about it. So it's the square root of 64 seconds squared. I'm going to put that into my calculator. Square root of 64 equals 8. So our final answer, t equals 8 seconds. So that's how long it takes to fall to the ground. Alright, so let's just erase some of this because we still have the second part of this equation to solve for. So just going to go through, erase some of this crap, and I'm going to leave the diagram and let's see, here we go. Oops, looks like I erased part of the problem, no big deal. Right. Erasing, erasing, erasing. Alright, so let's walk it back to u. And the second part of the problem is asking us to find the velocity when it hits the ground. So our unknown is final velocity. So we got our givens, we got our unknowns. The next step is to pick an equation. Pick an equation with final velocity. This one. This one is the most simple equation that we can pick. So velocity final equals velocity initial plus AT. And remember, in the last problem, we found that t equals 8 seconds. So now we have that in our repertoire. We can use that to solve for the final velocity. And we don't need to rearrange it. We do need to remember that this is 0. So final velocity is equal to acceleration times time. And so let's just go ahead and substitute in our acceleration, which is 10 meters per second squared, and our time, which is 8 seconds, and our final velocity is 80 meters per second. And that is our solution. So let's check to see if we got that correct. So I pulled this off of a website. Oh, there go the fish again. Where was it? Okay, here we go. So I pulled this off of this website, and you can see here time equals 8 seconds, velocity equals 80 meters per second. Sweet! So we solved that one correctly. Our first free fall kinematic problem solved. Alright, that's the end of lesson 2. Bye.